Functions that return a value. The second form of the return statement provides the function's result. Every return in a function with a return type other than void must return a value. Okay, the value returned must have the same type as the function return type, or it must have a type that can be implicitly converted. Alright. Although C++ cannot guarantee the correctness of a result, it can guarantee that every return includes a result of the appropriate type. Although it cannot do so in all cases, the compiler attempts to ensure that functions that return a value are exited only through a valid return statement. Okay, for example, incorrect return value, this code will not compile, and we are returning nothing. Okay, return, okay, that is a bool. Okay, although it cannot do so in all cases, okay. Incorrect return values, this code will not compile. Okay, functions that return a value. Okay, so let me go back, make two functions that return a value, and we will create this. Let's say, okay, wrong return types. Alright, so we got that, and okay, we have this function, have a bool, and then we have this. Okay, alright. Okay, let's auto size. Okay, so we have, okay, we are returning, so this is okay because we are returning a bool effectively, right? All these relational operators return a bool. Find the size of the smaller element, then we have this. Okay, so we are returning size, then no return value. Compiler should detect this error might flow of the end without a return, the compiler might not detect. Okay, the control might flow of the end of the function without a return, the compiler might not detect this error. Okay, let's try that. Yeah, okay. Oh, my bad. It's like how okay, yeah, so this is the return type, and that is a warning but not a control reaches the end. Okay, so it throws off a warning that control has reached the end of the function without a return type. We can handle it by treating warnings as errors, right? Errors, I think so. Yeah, okay. So yeah, this okay. The return from within the for loop is an error because it fails to return a value. The compiler should detect this error. The second error occurs because the function fails to provide a return after the loop. If we call the function with one string that is a subset of other, execution would fall out of the. If we call this function with one string that is subset of the other, one string that is subset of the other, okay, execution would fall out of the. Okay, if it is subset of other, so execution would, if string is not equals to, oh yeah, okay, if it is a subset, right, if it like subset as in we have say str1 equals a b c d and str2 equals a b quotes. So for this kind of function, it would just come out of the loop, right? There should be a return to handle this case. The compiler may or may not detect this error. If it does not detect the error, what happens at runtime is undefined. Okay. All right. Okay. So failing to provide a return after the loop that contains a return is an error. However, many compilers will not detect such errors. Okay, so we should always return something at the end of a function which returns values, which return like nothing, whose return type is not void. How values are returned? Values are returned in exactly the same way as variables and parameters are initialized. So you have the return value. The return value is used to initialize a temporary at call site. Okay, the return value is used to initialize a temporary at the call site, and the temporary is the result of the function call. Okay, so we are initializing a temporary variable, initialize a temporary at the call site, and that temporary is the result of the function call. It is important to keep in mind the initialization rules in function that return local variable. Okay, so we are returning here local variable. As an example, we might write a function that given a counter, a word, and an ending, give us the plural version of the word if the counter is greater than 1. Alright. That return type of this function is string, which means the return value is copied to the call site. This function returns a copy of the word, or it returns an unnamed temporary string that results from adding word and. Alright. So it returns a copy. As with any other reference, when a function returns a reference, that reference is just another name for the. That reference is just another. Okay. Just another name for the object to which it refers. As an example, consider the function that returns. Alright, so we are returning a reference this time. Okay, return a reference to the shorter of the two strings. The parameter and return type are references to const string. The strings are not copied when the function is called or when the result is returned. Okay, that's good. That is good. Okay. So which will return a value. I can make a directory called returning references. Then we can have maybe I should use the new print, right? Okay, so we can return a reference. can return a reference. Hold up. So we are okay. Right. Okay. So we are returning a reference to the same object, right? Right. So if I were to return a reference, okay. So if I were to return a reference to an int, let's say greater, right? That's how they did it. So we are taking, okay, and not a plain reference, a const ref. Okay. We return a const ref in order to make it read only, right? And we are also taking const ref, say a, b, and we are returning references. Right. So we are returning, say if a is greater than b, return a, also return b. I can handle the equal part. Okay. Then, but what happens if you return a plain? Okay, I'll get into it later. Okay, so we have int a, but then okay. And a equals 2, b equals 3. So we have a, b, and then greater a comma b. Okay. Dude, something is wrong. Is something wrong? Why isn't it writing something? Okay. So we have G++, CPP, print. No? Oh, sorry, my bad. You have to define standard C++ 23. And it goes actually before the compilation. CD C++ 23. And it still don't compile. Okay. .cpp. Fatal error. No such file. Huh. Really? Hash include print. Are you sure about that? Print. There is no such file. I think there is. PP. Let me go to exercises. Let me go to why isn't it working then? Right? The standard is C++ 23 and it should just make it, right? No such file on directory. Are you sure, my man? CC, man, CPP. Huh? What is happening? What do you need something? Oh, this has never happened before. Say set the standard equals C++23. I go .cpp. Do I need to link? Literally, what is happening? No such file or directory. No such file or directory. Yeah, okay, it is there. G++ GCC. .30. Okay, I don't. Okay, doesn't matter. Let me go live stream. Suppose it was 14.2. No? Why did it revert back to 13.3? Bash files. What is happening? Okay, this doesn't really matter. Okay, so we have C out. We'll take A. Of A. And B. Okay, my bad. Right, okay, so it would actually show that. But what if I pass plain references? Right. Which would happen? Okay, it's still valid. But then can I do that? Can I do the same? C equals because okay, greater of A comma B. So effectively I'm storing a reference, right? And then I update C to be 4, so B should become 4. Then if we print B, would it have become 4? I think so. Right, yeah, okay. So okay, but we cannot pass references to local object, right? I don't think so. So we can only pass references, plain references. So already to the references in the parameters, right? But we can't pass. References to local variables. Okay. That is it basically. So okay, no, delete that. Okay, got it. Okay. Okay. Right. Okay. Never return a reference or pointer to a yeah. Exactly what I was saying. When a function completes, its storage is freed. After a function terminates, reference to local object, local objects refer to memory that is no longer valid. Right. Okay. So correct. Disaster. This function returns a reference to a local object. Return empty. Wrong. Empty is a local temporary string. Okay, wrong. Returning a reference to a local. Okay, so we can't even return strings. Okay, because empty is a local string. Okay. Returning references. So here's an example, right? Here's an example that you can't really do that. Okay, empty is a local temporary string. Alright, string literals are also local temporary strings. So like there are no similarities in similar to C, because okay, but maybe because this is a separate function. That's why I think this is local temporary. But no, but it is not being pointed by anything, right? Okay, if I have a pointer to a char, so CPD, say let's call it P1. Okay. Say hi. There is a P2. Say hi. Okay, and if I print both of their locations, right? Yeah, that is okay. String. Constring ref. Okay. So string does not. String does not name a type. Oh, my bad. Okay, so we bring a string and using std string. Alright. Okay, so we have warnings here. Reference to local variable returned. And returning reference to temporary. Okay. ISO C++ forbids converting a string to a char star. Okay, so these are by default a string constant. So no, if I go ahead and high and high, it prints high and high. It don't like prints its address, right? Address that they print point to. Hold up. I would need to bring out or what is the value stored in these guys? Okay, right. See, okay, so they are effectively, yeah. So yeah, it somewhat works like that. That both the strings are the same. Okay, but temporary. But this is a temporary string. Okay, this is a local temporary string. So it would not be. So I think they are, both of these pointers are pointing to something. That's why it's being saved at compile time. But this is not being pointed by anything. So this is effectively a local temporary string. If I'm correct, we'll try to confirm. Let's see which chart.
Got something a little different for you all today. One of my best friends from real life
has to say for us. Okay. So when we return a local temporary string from a function, it gives a, oh no, yeah, but we are okay. Let me try that. Okay. Returning char star to a local temporary, but would it still be a local temporary string, right? Would it still be a local temporary string? Yeah. Okay. So would it be a local temporary string? Would it be a local temporary string? Let's see. I'll just let's see. Right. Takes nothing, right? And I'll again point p1 to hello, and then I'll just copy this. Then I just want to I want to see both the values, right? Right, so we have p1, p2. Then I want to return p1, right? And then okay, let's see if this compiles. Okay, yeah, everything does compile. Warning, const star 26, 27. So it don't. Okay, so it's warning. ISO C++ forwards converting a string constant to char star. Okay. That is the standard. But let's write. So we will write. Okay, so we have this, and then can I effectively catch that? Say string ptr from string, right? And would I be able to reference that? Because I believe that this will get stored. I think this will get stored in the data segment of the executable, right? Not yeah, data segment, right? Data. No, not data segment. That text segment, right? The text segment. Okay. So it will get stored in the text segment, and I should be, and it should so we'll print both. Okay, and so we have SPTR, and then SPTR again. Okay. Okay. Yeah. So yeah, I was correct. That it does get stored. It does get stored. But right, we are returning a reference to a local. We're returning a local reference, and if we try to catch that reference, then what happens? Right. String ret dot empty, not empty, return ret. Okay, so it is not valid. Right, standard. Okay, if I enable some standard, will it give me no, it don't necessarily give me an error. These are warnings. Okay, these are warnings. Okay. Right, yeah, so we can still point to this section. We can still point to this section, right? All right. But if you try to catch this reference, manep, right? Let's try to catch this into a string. If I go string s, hopefully there's nothing named s here, right? S into manep, and it is and then I try to print as okay. Okay, so it prints nothing because it is empty. No. Okay. So if it is not empty, it returns this. But if it is empty, it returns empty. So this is effectively undefined behavior. Then it should be undefined behavior, right? Both of these returns return an undefined value. What happens if we try to use the value returned from manep is undefined? In the first return, it should be obvious that the function returns the reference to a local object. In the second case, the string literal is converted to a local temporary string object. Okay, so it is being converted to a object. That object, like the string named red, is local is local to manip. The storage in which the temporary resides is freed when the function ends. So both returns refer to memory that is no longer available. Alright. Okay, so that is an empty. Okay, so this is a local temporary string, but when I point it to right, okay. So I was thinking, okay. Consider the following code. Let's see. How do I consider the following code? Let's copy it. call. Alright, so carefully separate what's happening in both cases. Const string reference, yeah, returning reference to a local object, reference to, yeah. Okay, so it is a local variable, it is destroyed when the function ends, so you're returning a reference to an object that no longer exists. Entangling reference, undefined behavior, second branch. Important detail. Okay, so important detail is empty is not a stud string. It is a count, acha, but since the function returns, okay, so creates a temporary string. Okay, and binds it to the return reference. However, that temporary stud string is destroyed at the end of the return statement. That temporary stud string is destroyed at the end of the return statement. So you again return the reference to a destroyed object. Okay, the string literal itself is not the problem. The temporary stud string object is the problem. Returning cast star, yeah. Now we are not creating a stud string. We are directly pointing to hello, which is a string literal. Where are string literal stored in C++? They have static storage duration. They usually live in the read-only memory, section. They exist for the entire program file. So this is safe. Because the literal outlives the function. Yeah, but there is a problem. This line. In modern C++, this is technically incorrect. Okay. It should be const char, yeah. Because string literals are const char. Modifying them is undefined behavior. Older C allowed this more loosely. Okay, settle point about this line. You may see some address printed or difference. Compiler allowed too much identical string literal. This is called string literal pooling. I know. Proper way to fix first mention. return by value, not by reference. Right. Okay. Okay. Now I get it. Basically, all right. So I can write that. In this case, we are okay. So yeah, so red is a local object and gets destroyed when the function returns. So any reference to it would also get destroyed. Any reference to it would also get destroyed. Then empty is a string literal const char. Is that 6? Okay, 6. And since the function since the function return for the same reasons that it is wrong to return a reference to a local object, it is Let's try it without the index, right? Okay. So what can I um okay, if okay, so we have to we okay, I can sort of make this variable, and then I can say that index is not equals to vi dot size of index equals to, then we can return, else we can go, else we can index, right, in sorry, yeah, okay, so it'll go like this. So I would not need to pass the index explicitly, but then I'm also like, can I do it without? Can I do it without? Can I do it without? What? Control. Okay. Can I do it without? Okay, with an array,